Okay, so welcome to week 3 of your online learning. Well, we're going to be looking at polynomial functions, particularly how to graph them. Now, when we're looking at polynomial functions, we're looking at the sum of monomials, and they usually have this standard form over here, with the exponents all in descending order, and we're just going to look at some key parts of it that'll help us to graph it. So over here, this n, this is going to represent the exponent. Over here, this a of n, this is going to represent our leading coefficient. And over here, this a of 0, this represents our constant. All right. So if we were going to look at an example of a polynomial function, it would probably look something like this. You've probably seen this function before. So this would be an example of a polynomial function. And just like and it's in standard form. Because over here, if you look at the exponents, it's in descending order, or it's from greatest to least. So the exponent's here 2. If I don't see exponent here, it's going to be a 1. And then over here, we have our constant. We just have our plain number without a variable. All right, so those are the components of your polynomial function. Now the ends over here, notice how they're matching, right? So the ends over here in a polynomial function, they're going to represent our degree. And we're going to see what degree means as we move on, but these are the parts that we're concerned with. Our leading coefficient, which is this a, our exponent, the degree, and that's going to be our constant at the end. All right, so let me just move on from this. So here are the common types of polynomial functions. We've seen this before, the quadratic function. But we also have, if your leading coefficient has the exponent 3, then you're going to have a cubic polynomial function. And if it has the exponent is 4, that means you have a quartic polynomial function. And notice here the degrees, so 0, 1, 2, 3, 4, it matches with your exponent right over here. So this degree, it's 0. This is a constant number. It doesn't have a variable, so the exponent here is 0. 1, if I don't see an exponent over here for this x, it's automatically going to be a 1, but usually we don't write it like that. We just leave it as a plain x. And over here, this 2, it matches with the exponent 2. 3 matches with 3 over here. 4 matches with 4. And just like in the other forms, they're in descending order, so from greatest to least. Right? Let's move on. So how do we identify polynomials, right? So whenever we're going to graph it, we need to identify a couple of things. First is we have to identify what polynomial function we're looking at, right? And we can do that if we look at the exponent, and it should be at least 0. So right over here, before I can even start graphing it, I have to see, is it a polynomial function? And if we look at the 3 right over here, the exponent, the leading one, well, any exponent, because this exponent is bigger than 3, right? This is a polynomial function. Okay, and the degree would be 3, and the leading coefficient will be -2, and 8 would be our constant. All right, so that's how we can identify polynomial functions if we're looking at the exponent. Let's look at a couple of examples. So let's look right over here. We have this function right over here. F of x is -0.8 x cubed plus square root of 2 x to the 4th minus 12. Now for me to identify if this is a polynomial, I need to look at the exponents. So I need to look at 3, I need to look at the 4, right? And I have to see if it's bigger than 0. Now lucky for me, they are bigger than 0, so this is a polynomial function. And then once I find out it's a polynomial function, I need to put it in standard form. I need to switch these two exponents. So the way I'm going to switch it is, so see how this is a positive square root of 2 x to the 4th? I'm just going to bring up the positive 2 x to the 4th. I don't need to put the plus sign. And now here, you see this negative? I'm going to put minus 0.8 x to the 3rd minus 12. All right, and I kept the minus 12 as is. So I just kept their, whether it's positive or negative, but I just switched the orders. And if you're going to switch the orders, you have to make sure that you're keeping them, if they were positive before, you keep them positive before. If they were negative, you keep them negative. This is when you're switching these expressions around. Now that I have it in standard form, I can identify what is the degree, which is 4, the leading coefficient, which is square root of 2, and then my constant, that's going to be a -12. All right. So now that I have that, now that I have identified that, I could go on to the next problem. And we're just looking at different examples so that you have different ideas on what to look for when we're trying to identify a polynomial function. So now we have this one over here, h of x is equal to -x squared plus 7x to the -1st plus 4x. So now I need to look at all my exponents. So right over here, I have a 2, I have a -1, and for my x, if I don't see an exponent, automatically assume it's a 1. And I have that over there as well. I'm just going to highlight a different color. So now, this 2 is bigger than 0, so we're good here. And then let's look over here, it's a -1. So -1, it's less than 0. So because we have this, it's not, the whole thing won't be a polynomial. So we would write not a polynomial because the exponent is less than 0. Now, it doesn't matter if this -1 was in the front with the leading coefficient or if it was at the end or at the middle. Because that -1 is there, the whole thing is not going to be a polynomial. All right? Okay, let's move on to a different example. Let's look at this one right over here. G of x is equal to 0.5 x squared plus square root of 3 x to the fourth plus 19. Again, I'm going to look at all my polynomials. Sorry, I'm going to look at all my exponents. So this is a 2, that's a 4. There's no exponent here, so that's a constant. All right? So if I look at it, yes, it is a polynomial because we have exponents bigger than 0. So it is a polynomial. And now notice here, again, it's not in standard form because this x to the fourth, well, that's the bigger exponent. It should be up front. So I'm just going to switch it around. And I'm not using inverse operations because I'm not moving across the equal sign. They're still on the same side. I'm just switching them over. 3x to the fourth plus 0.5 x squared plus 19. Okay, cool. So now it's in standard form, and I can go ahead and get my degree, which is a 4, my leading coefficient, which is the square root of 3. And now if they were asking me what type, right, I would just look back at my chart from before. So the degree was 4. I have a quartic. So let's go back. This would be a quartic. Okay? So that's how I'm going to identify that. Let's look at another example. Let's look at this one right over here. We have kx is equal to x squared plus 3 to the k power. Okay, same idea. Let's check all the exponents. Let's see. My 2 is bigger than 0. Okay, that's good. But there's an x over here. This is a variable. Okay, so this, I can't tell if it's bigger than 0 or not. So because there's an x here, it's going to automatically make the whole thing not a polynomial. It's not a polynomial. Now the reason why I'm going to say over here is because the exponent is a variable. It is a variable with a number as a base. All right. So because it looks like this is not a polynomial. All right. So for today's attendance question, we're going, hold on, let me just erase this. You know, sometimes it works, sometimes it doesn't. Okay, cool. So for today's for today's attendance, I'm going to give you guys this polynomial. So just by looking at this polynomial, is this, sorry, I'm going to give you this function. Just looking at this function, is this a polynomial? Why or why not? All right. Okay, and we're going to stop right over here. All right, so you're just trying to see if that last function is a polynomial for your attendance question, and have a great rest of the day.